all know that it is purely with the mechanical power. When we were able to integrate the electrical power with the mechanical domain, we were able to achieve the Industrial Revolution 2.0. And now, when the industries were integrated with the digital systems, that is PLCs, microcontroller, and other digital control systems into the industry, we gave a birth to the Industry 3.0. And what is currently, right, in most of the industries, we were able to see the Industry 3.0, and many of the industries are migrated to the Industry 4.0. The thin difference between Industry 3.0 and 4.0 is, in the Industry 3.0, if you are able to provide connectivity to the outside world. So the key concept is adding a connectivity to the existing industry will enable Industry 4.0 with advanced data analytics and making some decisions out of the ML and AI algorithms, which make use of the live streaming data. So you need to understand that the Industry 4.0 is the existing industry with connected. So in this case, what we are moving is called the Industry 4.0 enabled with the connectivity leads to a lot of security issues. Just a minute. I hope now we are in the slide METI. So this will give you, you can see there is a huge machine floor, and the machine floors are equipped with a lot of sensors, actuators, controllers, and many other things. And why we need to migrate from 3.0 to 4.0 by integrating the Internet of Things. The basic thing is to maximize the efficiency, to get the production data automatically, and to manage the shop floor remotely, and to optimize the resource utilizations. The ultimate aim is to have a quick decisions based on the ML and the AI algorithms. We are making the industry as a smart industry. So I can say Industry 4.0 as a smart industry, not only the industry, whatever the devices, when it is having the ability to talk to the outside world for pushing the data for later analytics, we call them as a smart. So the major thing is, when we say smart, the smart systems incorporate functions of sensing, actuation, control in order to describe and analyze a situation and make decisions based on the available data in a predictive or adaptive manner. So look at here, in a normal embedded system, we have sensor, actuators, control unit, there is no doubt. But when we come to the smart systems, in addition to the sensors, actuators, and rule-based control system, we are able to make decisions based on the live data. So when a normal embedded system get integrated with intelligence, by making it cognitive, we can say the system is equipped with the smartness. So basically the smart system consists of sensors for signal acquisition and the communication elements for transmitting the data. The command and control units may be microcontroller based embedded system or programmable logic controls, depends on the complexity, that will process the data and take decisions. and the decision taken has to be communicated back to the industry. For that, we need the communication modules, and whatever the decisions, right, communicated should trigger or actuate the actual actuators, the output devices in the end devices to control the environment. So in a nutshell, we can say sensors, communication devices, control units will make a system smart with edge intelligence or the intelligence inferred from the algorithms running in a cloud environment. So we can say that the current generation smart system combine technical intelligence and cognitive functions so that they can provide an interface between the virtual and the physical world. Now, why we are giving an introductory part about the Internet of Things and the smart system is, first we need to understand the importance of an IoT. At the same time, when it is exposed to the outside world, what are the challenges associated with that? What are the security challenges, right? That has to be addressed to make my IoT system and applications more secure. So for that, first we need to understand the various enabling technologies related with the smart system. So the smart systems and IoT are driven by a combination of sensors, actuators, connectivity, that is the communication modules, people, and the process. So here the people and the process are going to play the major role. So in a simple term, we always say IoT as an integration of operational technology, that is the core engineering, industrial engineering, operational technology with the information technology. So IT plus OT is nothing but IoT. What you are seeing is a simple embedded system in which you can see there is a sensor which will acquire the physical data and push the data through a wired or wireless communication medium to the control center. The control center may be a simple embedded system. And based on the decision logic running in the control center, an action will be taken whether to turn on or turn off the sprinkler or not. It's a very basic embedded system, sensor to actuator flow. But I have no information about when the temperature exceeds the upper level, when it falls below the lower level, when the actuator was actually switched on, how long it was switched on. I have no such a data. So to make the system smart, I need to communicate all this event, all the data particular to that particular event to a, say, either it should be in the local storage or in a remote storage unit. To store it in a remote storage unit, I need a communication interface. So whenever we have a communication interface, the security will be an issue. So look at here. This is a very basic, say, machine-to-machine communication. For example, if I want to switch on a fan in my home, or a geyser or a water heater in my home, so through a mobile phone, by sending a message, switch on. If the water heater in my home is equipped with a GSM SIM card and associated embedded system, whatever the message I am sending, say switch on, switch off, according to the content, the water heater in my home will react. So This is called the basic machine-to-machine communication. So in such a cases, there are two important things. I need to have a connectivity between my mobile phone and the device which is at my home. And the next thing is the content. Based on the content, switch on, switch off, the device will react. So if you look into any machine to machine, there are two C's important called content and connectivity. What are the additional four C's for machine to machine communication? So to qualify a M2M as an IoT, I need four C's additional. The participants can think about that. I hope all of you have in your mind the additional C is nothing but the cloud. Can you guess three more C's? I will give 10 more seconds for you. In the next slide, we'll give you the complete picture. Anyway, you just think about that. What may be other three C's? Fine. So just check your answer. The other four C's are nothing but the cloud, collaboration between the different services and systems, the context, whether it is a smart agri, smart healthcare, smart transportation, smart energy, the context aware. And the most important thing is every IoT system should be intelligent enough. The cognitive function integrated with your IoT system. So to conclude the basic understanding of IoT, I can say the IoT must have the connectivity, content, context, collaboration with other services. It should be intelligent by enabling with the cognitive functions and at the same time to handle the big data and to run the complex predictive analytics. We need to have a cloud platform also. So these are the 6 essential things for making any system as an IoT ready system. So now coming to the basic setup of any smart system, this slide will give you a very good idea that the embedded systems or any end devices will have sensors and actuators. The sensors and actuators, sensors are the input devices, actuators are the output devices. They will be connected to a microcontroller. The microcontroller will have the associated communication interface. Here in this case, it is Wi-Fi. Here in this case, it is a Wi-Fi. And through the Wi-Fi gateway, it gets connected to the cloud interface. So look at here. Look at here. The very basic concept is I have sensors and actuators connected with them. I have sensors and actuators connected with the microcontroller based embedded system, which is having a wireless interface. Through a Wi-Fi gateway, I get connected to the cloud. This is a very basic setup for any smart system. And now the next 3 slides will give you a quick idea about the various important concepts related with IoT components. For example, we have to select the appropriate sensors. For example, if my basic thing is a HVAC, heat, ventilation, air conditioning, then I must have a temperature sensor and a humidity sensor. And if my work is more related with water management, then I need to have a leak or level sensors and so on. So I need to select proper sensors and actuators, and followed by the connectivity. Whether I need to get connected through a personal area network within 10-meter space, or I have to connect to a local area network, which by theoretically within 100-meter, or I need to connect to a wide area, say few kilometers or few tens of kilometers. So depends on the need, I have to select the appropriate communication interface. The popular communication interface you can see in the slides are the RFID and near field communications, 6 low power wireless personal area network, Zigbee, Z-Wave, ultra wideband, Bluetooth, all these falls under the personal area network. And in the local area network, we have a Wi-Fi. And for the wide area network, we have a different technology, maybe cellular based or non-cellular based. And the most important thing is any practical IoT applications should have to integrate the people who are the end users with the process that is the actual operational technology. So this is the must for any IoT system. And this is another bottleneck for the security weakness also. So we will have a detailed discussions about the various security weakness associated with IoT devices and the basic resolutions for them. So to conclude the IoT and smart system, we have a clear idea that it is a combination of sensors and actuators with connectivity integrated with the people and process. So look at here, what you are seeing is a different popular maker boards which can act as end devices or edge devices in an IoT end devices. So what you are seeing is an Arduino, very popular Arduino Uno board, but it has only UART, that is a serial communication interface, basically a wired. And in the right side, you can see a node MCU, which is an Arduino with wireless Wi-Fi interface. And you can also see the industrial grade ST microelectronics based microcontroller board F103. These are all few samples which you must know about that. And you can also see the Raspberry Pi based single board computer, which is a powerful, and currently what we are having is a Raspberry Pi 4 version, as well as 5 is also in the market. So the Raspberry Pi is a single board computer which can serve as a edge devices between the end and the cloud. So the Raspberry Pi is also has a built-in Ethernet, wired Ethernet, wireless Ethernet, Wi-Fi, and it also has a built-in Bluetooth also. So now we are in a position to design a simple IoT device so that we can understand the various security vulnerabilities. So what we are taking is a very basic popular IoT device called ESP32, which is a dual core 32-bit microprocessor with 520 KB of SRAM and 448 KB of read-only memory. It supports 802.11 BGN standard Wi-Fi connectivity. It also supports Bluetooth version 4.2, and that is basically a Bluetooth low energy with secure boot and flash encryptions also. So now coming to the security part, when I connect any sensors to my IoT control and command unit, I need some interfaces, right? So these are all the wired interfaces, which is more secure compared to the wireless interface. Basically, for the sensor interface, we will have the analog, direct analog interface, which is done through an example is LM35, all are temperature sensor, but as a different interface, you can see. And there is a TC74, which is a two-wire interface called inter-integrated circuit interface. And another IC is called TC72, which is a four-wire interface. So basically, these are all the ports through which the sensor has to push the data into the control and the command center. If anyone has an access to this wired interface, the ports, there is a possibility of manipulating the data. So the interface, the communication interface for connecting the sensors, whether it's a direct analog interface or two-wire I2C or four-wire SPI, there are possibility of getting a direct contact with the microcontroller interface and to manipulate the data to attack your IoT end devices. But keep in your mind, the physical tampering is really a challenge if the environment is a secured environment. That is a physically secured environment. So the more vulnerability will be with the wireless connectivity, we will discuss later. So now coming to the communication interfaces of any IoT devices, we have three popular wired communication interfaces. That is the UART, Universal Asynchronous Receiver cum Transmitter, through which most of the wireless devices will be connected. For example, the Bluetooth, popular Bluetooth, may be connected to an Arduino interface through TX and RX. Very simple thing. Transmit pin and receive pin. So by connecting the TX of a Bluetooth chip to RX of the Arduino and RX of the Bluetooth chip to TX of the Arduino Uno will be enabled with BLE. So similarly, the UART can be used to make your any IoT devices as a wireless ready devices by connecting BLE model, Zigbee, Thread, or even UART based Wi-Fi model, whatever it may be. So that is why in most of the IoT devices, the UART port is a more secured port and it is not exposed to the outsiders, and always they will disable this board. That is why your modern computers and laptops will have no UART exposed to the outside world. So look at here, when we come to the industrial side, so we have two popular protocol, the interface called Modbus, which is done through the physical interface called RS485. You can see there are two wires called A and B. The A and B stands for the signal cables. When A is more positive with respect to B, I can say logic 1 is transmitted. When B is more positive with respect to A, logic 0 may be transmitted. So this is for connecting to a PLC or smart energy meter, which talk through the Modbus, which is a very popular industrial communication protocol. And when we come to the automation engineering side, we have another popular protocol called CAN. So in the CAN also, you have two-wire cable called CAN high and CAN low. So you can see all these things are connected to the microcontroller either through RxTX or through some special pins provided for interfacing of the RS485 or CAN interface model. So we had already discussed about the interfaces for connecting sensors and actuators like the direct digital IOs or analog IOs or SPI or I2C. And in this slide, we also discuss about the communication interfaces like UART, Modbus, and CAN. So these are all wired, and you can see a simple test bed in which you can see a PLC connected to a smart energy meter through a Modbus. And we also have Siemens IoT gateway that is also connected to the system through the Modbus, and the SCADA and the PLC software. SCADA is a network software for the industrial IoTs. So it is running a host. A laptop is serving as both the PLC programmer as well as the SCADA server. So this is a simple IoT, industrial IoT test bed where you can also inject some of the attacks, and you can also provide the mitigative solutions for securing your industrial IoT system for such attacks. Now, coming to the core concept. So if you look into any of the microcontroller, okay, so the microcontroller itself will provide a secure world. So you can see in the slide, there is the LSB, least significant bit, labeled with NS. NS is called non-secure or the normal mode. So when it is 1, the microcontroller will act as a simple, normal standard microcontroller without the secured mode enabled. When I am making this LSB as 0, you can see in the right side, it will switch from the normal world to the secured world. Then only you can access the secure configuration registers. You will be able to access the real-time clock, the GPIO, I2C, and some of the interfaces, okay, which needs more level of security. So for your information, this ARM Trust Zone technology is an upgraded version of trusted platform model. In the trusted platform model is a very important thing where we will store our key important things. For example, the encryption keys and the secure boot configuration registers and everything will be in this placeholder that is nothing but the trusted platform model. So nowadays, the microcontroller itself is providing a security by enabling the ARM Trust Zone technology by making the least significant bit of the secure configuration register as 0. And wherever the security is not important, you can make the LSB as 1 to run in the normal world to speed up your process. And whenever security is a major concern, just to make the LSB bit as 0 to switch into a secure world. And now coming to the connectivity options, we have a short range high speed like Ethernet, Wi-Fi, short range moderate speed like Bluetooth, Zigbee, Z-Wave, Google Thread, and the popular 15.4, which is the physical and data link layer for the Zigbee and other short range, right? Moderate speed wireless protocols. And the most important thing is when we come to the long range and high power, we have a cellular, satellite, microwave. But look into that, it is divided into 2 major categories. One is called the cellular low power wide area network. The NB-IoT is very popular. For example, the Mumbai city, along with the Mumbai Telecom and the Tata Telecom, in association with the Semtech, which is the manufacturer of LoRa, they had converted all the gas meter into a smart meter by enabling the LoRa technology, low power wide area network technology into their gas meter. And similarly, we have a non-cellular LP WAN, that is LoRa Sigfox. So when we come to the cellular LP WAN, it is NB-IoT. When we come to the non-cellular LP WAN, LoRa. So there is a small correction for the NB-IoT. Okay, the Geo provided the connectivity solutions, and for the non-cellular, Semtech. Semtech is the original inventor and the designer of the LoRa. LoRa is a non-cellular low power wide area network. So for the non-cellular, you need not depend on the third party. You can set up your own low power wide area network based on your use cases. Now the question is, we have discussed about many, right, short range, long range, moderate speed, slow speed, and many things. When we are connecting that our IoT systems through a wireless interface, there is a security challenges before us. For example, if you look into that, for example, when I want to do some transactions through my credit card or debit card in a POS point of sales, I am in a position to physically enter the keys. So there is a possibility of shoulder surfing, where there is a shoulder theft of my PIN number by somebody through the shoulder surfing. So this is a potential area where I may, right, lose my PIN, or my PIN may get compromised. But in the modern world, what is enabled is most of the point of sales terminal were enabled with the short range wireless communication interface called near field communication, NFC, in which just tap your cell phone with the POS, point of sales terminal, your secret PIN, 4-digit PIN will be exchanged from your mobile phone app to the POS. So there is no possibility of shoulder surfing or shoulder theft of your secret PIN. So this is how nowadays, right, we are providing some kind of security to your IoT devices. This is one of the a simple example. Now coming to the Wi-Fi, okay, so the very popular and currently deployed solution is called the wireless protected access to pre-shared key, which is nothing but when I connect my laptop to my mobile phone, which is working as a hotspot, my mobile phone will have a SSID, service set identifier, and I need to know only the password of my hotspot. So by connecting to my SSID and by providing the proper password, I will be able to get connected to my Wi-Fi network. This is called the Wi-Fi protected access pre-shared key. But the thing is, if the password is weak and if it is easily guessable, the third party can sneak into your wireless network. So the next level of security is called the WPA to enterprise, which uses a central authentication server. You can see the bottom one shows the WPA to pre-shared key, where there is only the password is protecting your system, whereas in the enterprise, you have a central authentication server. The authentication server will provide a unique username and a password. So in addition to the service set identifier, you need to provide the username and password that will be authenticated by the central server, maybe a radio server, remote access dial-in user services. And this is a next level of providing kind of security. And the researcher says that even WPA2 is compromised through a crack protocol. And that is why nowadays the people are migrating from WPA to WPA3. I request the participants to explore more about the WPA3. You need to explore what are the security weaknesses associated with WPA2 and why we need to migrate into WPA3 also. Fine. Okay. So now, if you take any IoT system, we can have a layered approach. This is called the IoT World Forum reference architecture, in which the bottom layer contains the physical devices, second layer contains the connectivity where Zigbee, Bluetooth, whatever it may be, and the third layer contains the edge computing, maybe a Raspberry Pi based single board computer, and the fourth to fifth layers and are called the cloud. That is the remote layer where big data will be handled and where your MLAI algorithm will run, and the people and the process, right, the end users and administrator has to make use of your IoT system through the applications. So this is a 7-layer approach for any IoT system. And my question is, okay, which layer needs more security? So think about that. I will give you 5 seconds. Okay, which layer needs more security? So probably most of our answer will be the connectivity, because the connectivity is exposed to the outside world. Okay. And some of the computer science students will say the application level security is also very, very important. So it is not right with the single layer. It should be a holistic view, the complete view of providing a security to secure your entire IoT system. So in the physical layer, you should be able to have a secure silicon that is called the trust zone, ARM trust zone. And in the connectivity layer, you should choose the proper secured communication protocols. And when the edge computing device gets connected to the cloud, you should be able to choose the proper encryption techniques and the proper secure communication protocols. And in the cloud, your data storage environment should be both hardware and software tamper resistant, and it should be a secured storage. And when we come to the authentication and authorization, when we come to the application level, right, every user should be properly authenticated, and every user should have their own rights, the access rights through the authorization mechanisms. So the identity management, authentication, authorizations, everything is related with the top layers. So it is not with a single layer. We need to have a holistic view of securing your entire IoT systems. So coming to the communications, normally HTTP is very popular to all of us, but when we come to the IoT, you are in a position to explore further about the message queue telemetry transport protocol, MQTT, and the constraint, because most of the IoT devices are constrained devices. You must be able to know the lightweight HTTP called COAP, Constrained Application Protocol, and as well as you must also able to how to switch between HTTP to WebSocket and to make use of the advantages of bidirectional, right, the communication session establishment between the devices and the server through the WebSockets. So the MQTT, CoWAP, WebSockets are IoT specific application protocol, whereas HTTP is a traditional. We all know that the HTTP in basic will send all request and response through a plain text. So there is a lot of security weakness when we are transferring the data in a plain text. Therefore, how, right, you can see, right, in the bottom, the text is very plain, right, hello world. Okay, so it is a simple get request. You can see you are having the plain text, right, transmitted between the client and the server. So naturally, the HTTP request and response in the plain text is more vulnerable. And how you can secure this protocol? So you all know that we need to go for the HTTP secured. So the HTTP corrects this problem by using the transport layer security, TLS. So TLS is nothing but an updated version of SSL. SSL is nothing but the secure sockets layer. So you should be able to explore further about HTTP and how the HTTP secure your transactions between the client and the server by adapting the TLS certificates. So look at here, when you are enabling the HTTPS, the text, right, or the data communicated between the client and the server are not in the plain format. They are in the encrypted format. So those not having the proper keys, session keys, it will be a chunk of zeros and ones. They were not able to have a meaningful information out of that. So this coming to this, you should be able to understand some of the key concepts called what is called the authentication. It is nothing but the process of verifying the user. Authorization, which is nothing but the process of verifying what is your access rights. And you should also know the basic terms related with encryption, descriptions, symmetric key algorithm, where the key will be common between the sending side and the receiving side, and in the asymmetric key, where the encryption and the decryptions will be done with the two different keys, but somehow they were related. Okay, so now particularly when we think about the HTTP, it is a plain text. When we think about the HTTP, yes, it has an encryption mechanism through the TLS certificate. So all of you keep in your mind, the HTTP is making use of the traditional port number 80, whereas HTTPS is making use of the port number 443. So through that, you can also understand that, okay, whether I am enabling the HTTP or whether I'm using a HTTP or HTTPS by seeing the TCP port number. If it is 80, it is a plain text. If it is 443, it is enabled through HTTPS. So basically, HTTPS is making use of the public key infrastructure, the asymmetric key encryption. So you can look at here, the sender will encrypt using the public key of the receiver to encrypt the data. And through the communication channel, it is not in plain text. It is a ciphertext. For the others, it is a chunk of zeros and ones. And the receiver, they have to decrypt the ciphertext into the original message by making use of their private key. So all of you look at here, the public key of any user is available in the public domain, that is the root CA, certificate authority, but you need to keep your private key as confidential as possible. So the encryption mechanism which make use of PKIs, in the sending side, the document will be encrypted, the data will be encrypted with the public key of the receiver, and the ciphertext will be through the communication channel, and the receiver will be able to get the original text by decrypting the ciphertext using his own secret private key. So you are in a position to explore further about this PKI also. So I am giving many areas where you need to explore further to get the clarity about what are the things you need to secure your IoT systems. So basically, to conclude, right, the HTTPS is using the public key cryptography, using the public and the private key. And this is, right, a simple test bed for the industrial IoT to have more hands-on in understanding about the various, right, potential security threats and how to provide mechanisms to secure my IoT system. So with this, I will conclude my sessions related with the introduction to IoT security, and the forum is open for queries. Over to you. So I hope I had given a basic idea about from the devices and the interfaces for connecting the sensors, as well as the communication interfaces, and also the complete, the 7-layer architecture of an IoT system, and the adapted security mechanisms for all the 7 layers. We also discuss about the general, the traditional application layer protocol HTTP, and how to secure that using the HTTP secure, the basic public key infrastructure adapted in the IoT environment, and also a slight introduction about the various IoT specific protocols like MQTT, CoAP, and WebSockets. So I request the participants, anyway, this material will be shared to you. I request the participants to explore further about these various terminologies, even the hardware level, right? Trust zone, trusted platform model, secure boot. So these are all the terms, right, introduced to you. Based on your interest, you need to explore further. And if possible, you should be able to, right, set up a small test bed like this so that you will be able to get some hands-on, right, in the IoT security. So over to you for any queries. Over to the organizers also.
Yeah, thank you so much, sir, for such an informative session. So for the participants, I have you guys can unmute yourself, and if you have any queries, you can ask it to Anandaran, sir.
Sir, I hope the purpose was met, right? Since it is
Yes, sir.
an introduction. Yeah, okay.
Yes, yes, absolutely, sir.
Thank you. Suppose if you are not having queries currently, so you go through the material, and if you have any specific queries, right, you can contact the organizers. Okay. And we are happy to give much more information about that. Okay. And each area, right, for example, if you take the hardware level security, okay, how to enable the secure boot, everything is a separate dedicated right sessions are there. How to secure, right, the MQTT through the MQTT secured, okay, with the port number 8883. So for each and everything, for different layers, right, we have a separate sessions. So based on your interest, you can approach the organizers. We are happy to share the informations. Thank you. Thank you all. Thank you, sir.
Thank you so much, sir. So for the participants, I'm sharing the website link. So as it was for the last Saturday as well, you can go to the website and you can see the click here for the quiz button and you can attempt the quiz. Thank you so much, sir.
Shall I conclude now, sir?
Yes, sir. Thank you.
Okay. Thank you all. Thank you, sir.